we'll finish the FRDPARRCs for the first few minutes for the folks that haven't had the chance. So anybody online that haven't had the chance to finish and talk about their project yet? And then Ben, do you want to just present even while Adil is not here? If you have the file, it's okay to just go through it. Oh, he has it. Okay. And is from the folks that are online, is there any team that hasn't presented yet? Oh, Deborah, you haven't had the chance to present that yet, right?
No, I haven't.
Yeah, I think
that could do that.
Team members. So if you haven't actually presented your project, nobody else would know, and hence nobody else can recruit. So yeah, I guess in queue, Deborah, you can go first. Anybody else? For folks that haven't presented their FRDPARRCs? I think, Prabha, it might be useful to just present even now, even if it's brief, 2-3 minutes, just a broad class. I think it's very clear. The problem that you've identified is very clean. It's clear. It's a great way to recruit team members, just so that folks that haven't found teams yet, this is a fantastic way to see that, okay, this problem resonates with me, has the kind of skills that I want to pick up. So why don't we do this? Deborah, you should just go ahead and you can show what we were discussing just yesterday itself, very briefly, but just define the functional requirements for the project. And this would also be, I know you are looking for more team members, so this is the pitch recruiting too.
Awesome, I do that. Let me just share my screen. You see that? You see my screen, right?
Yes.
Perfect.
You want to do a one-line intro, just so people know?
Yeah, sure. So, hi everyone, I'm Deborah. I'm from Germany. I live in Dresden, work in Berlin. I have a group, we do image analysis there, and I was part of the Frugal science class, the first class in 3 years ago, I think. Mm-hmm. And the project that I want to work on is the one that Manu pitched originally when he shared this paper where they estimated human poses by using the Wi-Fi network, and we're thinking of how something like this or other solutions can be used to detect humans or animals in earthquake debris. And so far I'm alone here, so anyone who needs a project and feels inspired by this, please join me. So the functional requirements that I came up with here include that the system that we would come up with needs to be self-contained and not depend on an existing infrastructure, because there might just not be one anymore. Then human detection might be sufficient. It doesn't necessarily need to be the whole pose, but we need to somehow differentiate between humans and walls, for example, or what else could be in debris, and that's very diverse potentially. Then the humans that we want to detect potentially can't move, and the obstacles might be there might be many walls, and there are just like some limitations there. It should work indoors and outdoors. I think factor like rain could really mess with systems here. And so the effective penetration depth, this is what I also talked to Manu about yesterday, is something that needs to be described precisely so that we know which systems would match this. And we also need to consider privacy and ethics here, because looking into something that is usually not see-through is, of course, an issue if you provide everyone with a method to just simply do that.
Yeah. So
Please feel always free to jump in and add something, right?
I think before diving into design, any comments on functional requirements? What do people feel is missing? Any comments on what else needs? Yeah.
Maybe there needs to be like a specific distance as well, because I could imagine like if there's a very large building that you want to measure, you might not be able to set up like, for example, if you're doing like what the dead spoke like Wi-Fi router thing is, like the Wi-Fi routers might be so far apart that you can't actually like look in. So maybe having just a distance requirement would help. I mean, I guess there's a penetration depth, but also like what area size you want to scan might be helpful.
Yeah, I think just like effective penetration depth, there is an effective volume that you're trying to scan. And I mean, I'm sure this is obvious to everybody. This is really all designed around earthquake relief. So you're standing right in front of a building or a shell of a building that has completely collapsed, and you want to know whether there are people trapped in it and possibly their health state. And you need to do that. Every second counts. You've all seen the thread from Turkey and Syria, but this is a long-standing issue forever. There are lots of people that are trained in removing debris, getting people out safely, because it's an unstable structure. And so while trying to get someone, that thing can collapse. But on the other hand, we don't really have any imaging technologies and tools in that scenario. And every minute counts. So that's the other part. And I guess on the effective penetration side of the story, one thing that would be valuable is whether the system is multi-point or single point, one transmitter, one receiver versus, because the hardware that we are thinking about for this is literally wireless routers. They are ultra cheap. You can literally imagine a larger scale multi-point system, which is not what people initially were thinking about in DensePose and others. I guess portability you already spoke about. Anything else that?
I had a question. I'm not sure if this was discussed, but what is? Sorry, Manu.
No, go ahead, Alankrit.
Yeah, I'm just saying, how is it done now? I mean, is the only way to do it is just by removing the debris, or I'm not sure, maybe something like sonar, do people use that, or I'm not sure how it's been done like right now.
Yeah, the unfortunate bit is there is really nothing in this space. There is a lot of tools and technologies that were first built in the context of cameras and robotics. They're not very common. Certain sets of cameras on sort of very small cross-section area robots that people can put in. That's one way. I think sound is sometimes used. Sound is a very tricky one. You can imagine the amount of chaos associated in a collapsed building and around it. So, the unfortunate reality is, as far as I've read, nothing exists in this space.
Okay, all right.
Yeah, but I think it's lack of imagination, because we always assume we can't see through walls, which is technically not true.
Right.
So I find sound quite interesting actually right now, because if there is already lots of sounds, maybe recording them at different points could also be interesting.
Yeah, and
Yeah,
I think Subhir had a similar point.
Yeah, so thinking of which frequencies are interesting would be one part of that I have like here right now as the design parameter, which frequency is actually the most useful one, which can ideally pass through walls, but is detects interference with humans and can create it and measure it at a low cost. And we are currently exploring Wi-Fi here. The idea would be for the analysis part to maybe just really use a phone and a router and go somewhere, or use objects and put them in between and measure things. And there's also a paper that, like an article here about talking about values for wall attenuation. I think at risk factor here that I put in is rain and like anything that contains water that's in buildings and that can also just break and very much mess with this. Not sure how to countermeasure this.
Yeah, no, I think the way of thinking about the risk is water bodies would have similar absorption. That's what we are detecting for.
Yeah.
But the other point of that, in a collapsed building, you have to have humans have a certain volume. Humans
Mhm.
have, there is an anticipated absorption associated with it. And the other part of that would be is water tanks and other things leak. So yeah, it's
Yeah, but like wet blankets, for example, or stuff like that could
valuable
have a
to
similar,
valuable to think about, but all of that could just be tested.
yes.
One
yes.
big risk, which I think it would be fun if you show folks the current simulation that you've been running.
Mhm.
One risk I can think of is that unlike the classic case of a room that's clean and you're trying to detect pose of people, there are incredibly high number of reflection points because the debris
Yeah.
by definition is a massive number of surfaces with porosity. And what we have to really think about is signals and reflection and how much, as you add more reflections, how much information you can even extract in system that has very high number of reflections. And the
Yeah.
simulation that you did that we were talking about yesterday is actually fun. If you want to just show one image of that.
Yeah. It will just rush through these and then we can go to this because I agree it's the most interesting point. So just what we are talking about now is a system with senders and receivers in order to collect signals and get some kind of joint information from these. And in order to do this, we need to know the spatial configuration of these senders and receivers. So we need as accurate positions as possible of these. That's like one of the design parameters that would have to be solved, and that like these are separate tasks which we could also easily split up between people, for example. Then like we need to figure out how precisely one can measure the signal strength. Actually, I never tried the how well you can receive the strength of Wi-Fi signals with a phone. That will be interesting. And then the actual most important step is what do you do with the information that you get, and the paper that Manu shared with the combining Wi-Fi and dense post sadly doesn't have any open source code related to it. But before going to something that is in a deep learning domain, the idea would be now to first find the visualization way of the signal so that we can grasp what we actually see. And in order to do this, I tried going like a simulation way, and this is like a first naive way of just basically ray tracing. I will show you in a moment. So this is the ground truth here on the left, basically. So the black is the background, and then I position random objects on there, and the color is the absorption rate. The brighter it is, the higher the absorption. And then I place random lines here from one border to the other. I calculate the average absorption, and I played with different ways of visualizing this and different strategies here. And you see that you definitely can see things, and that very much differs on the algorithm. But this is not including any reflections. So the next step would be to look at simulation tools, existing simulation tools for EM, and there are a bunch of them, and that would be something that I would explore next.
Yeah, and has anybody in the class done any open source tools for FEM? The only one I can imagine is maybe Baba. No, yeah. So I think there is a really fun class of open source tools, probably FDTD related tools. You can put arbitrary geometries, you can excite a signal, and you can watch. And I think it's a little bit of this, it's an information bottleneck kind of a problem, that as you add more and more complexity to the number of places that the signals are getting reflected, the information is getting, it's diluting out. And so effectively, what is that threshold point in a debris that you can still actually pick it up?
And the
yeah, no,
one
I
thing
think-
that we're wondering to in order to improve this is to include more receivers, for example, by, for example, throwing them or putting them somewhere where they can, like, for example, crawl into the debris. That would be cool. So that we get more measurement points from different locations also inside, because that would include, that would increase the precision of the result a lot.
Yeah, and I think this is a call. If folks are excited, it would be fantastic to join the. Right now, Deborah is working alone. This is a very important problem. There's some very straightforward simulation-related things we can do. All of you have RF hotspots in your homes. The measurement for just how much RF goes through is pretty straightforward. You just walk a number of distance. You see how the signal goes down. That's the primary readout. So I think, yeah, there's going to be lots of experimental work in the project. And so anybody who's, even if you have never done any RF or EM related things, this is a great place to learn. Yeah, and we should actively try to recruit more number of people. I think working alone is always hard, but I think this is an exciting enough project. We're going to push through this, Deborah. Okay, let's jump to other FRDPARRCs. I see Adil is back, and then Baba, if you want to give a one-line pitch for it. Are you also working alone currently? Yeah, so maybe this would be a good time. You want to just come up and say a word about the project? And then Adil and Bem, do you guys want to just say a word? Yeah. I know we haven't had the chance to talk, but at least we should get a chance to get the thread going. And then, is there a place I should open, Baba?
I guess the FRDPARRC that
Yeah.
I looked at yesterday.
Yeah, you were. I think the class was ending, so I just thought I'll just.
Yeah, no, that's okay.
I-
Really did a great job.
I told people a few things.
Yeah, yeah.
But I think in a recruitment point of view, it's actually. Oh, did I just? Oh, there it is.
Yeah.
And I will share my screen. Okay.
Yeah. Okay. So I think Manu presented this yesterday, but for this project, I'm really interested in kind of what we talked about like the first couple of lectures, which is malaria diagnostics. And specifically, I'm interested in, like, guess what Manu and I are calling the thin red line problem. This like high prevalence of false negatives in malaria RDTs. And for the sake of the FRDPARRC, I wanted to be very specific in my geographical location, try to just be as specific as possible. But there are kind of like two sub problems for this number of false negatives, and that's like low parasite densities, malaria parasite densities, and then this uptick in parasites or plasmodium that lack this specific gene which codes for some antigen which is detected in this RDT. And so basically I've been thinking about different approaches to either attack one or both of these two different sub problems. So I guess I can. You said just one thing. Sorry.
No, you should explain it.
Okay.
Yeah, I think it's useful to recruit people. Yeah,
Okay.
so.
Okay. Cool. So here for my functional requirements, I have kind of just standard functional requirements for RDTs. So things like high sensitivity and low limit detection, and I kind of define these parameters based on things that I read. Things like easy interpretability, temperature stability, since this is going to be in the Horn of Africa, so temperatures like above 38, 39 C. And then pretty much like any of the World Health Organization's assured criteria they should follow. So like I said, this problem I see it as two mini problems, and the first one is like a measurement problem, or like how can you equate parasite concentration to some easily detectable, like measurable change. And like the standard way of a lot of RDTs is a colorimetric change. So you equate antigen concentration to some red line. Like if you have ever taken a COVID test, which I'm sure everyone has, you're like, oh, I hope I don't get the red line. You see the red line. and COVID.
Everybody understands the thin red line problem, right? Here is, okay. Is it obvious? No? Yeah. Can you just explain to Adil?
Yeah.
Why are we calling it the thin
Yeah.
red
So,
line?
so if for COVID, I'll just use the example of COVID test. If you want to know if you have COVID or not, and all these like, you take a swab and you put it in the test and you look for this red line, this color that indicates that you're positive or not. The problem is sometimes that line is very like faint, or it's a little hard to know if you actually have it or not. And that's really a problem with malaria RDTs. And so because I see this like subproblem as a measurement problem, I was just thinking about different ways that you can detect some change based on antigen concentration or nucleic acid concentration or something. So I kind of just listed a couple of ideas I had, like I have an optics approach using like refractive index based sensing, and an electronics approach, which I've been talking to you about, if you can detect some change in like resistivity or conductivity based on concentration, some acoustics approach, which is really interesting. Like you have some type of piezoelectric, which vibrates at some frequency, and that frequency could change based on binding, stuff like that.
And then just so when people think about where that red color actually come from, there is already lots of techniques in which you can add, either gold nanoparticles, silver nanoparticles. So there is already a substrate that's there. Just the mistake is that we are saying, oh no, you have to detect it by eye, which makes no sense. So I think rather than chemistry doing all the work, you want to let chemistry do some of the work, but then have some gadgetry on top of it, read out the next. And I think lots of places which quantify by taking photos already are in that direction, but they're not truly amplifying. So I think we're kind of looking for an amplifier essentially, somewhere in the middle.
Yeah, exactly. Yeah, the human eye is not the best tool that you can use to detect things. So it's like, how can we use one of these approaches to augment what we currently have?
And then if anybody has been to a primary health center, it's dark and it's not the most well-lit area. It's there's probably other just maybe going away from optics from that is actually a very interesting approach.
Yeah, so those are kind of the ideas for that first subproblem. For the second problem, so I guess as a reminder, it's the fact that a lot of these parasites are lacking this particular gene, and so you need other things you can detect. And so I didn't get too far in thinking about this, but a couple of ideas I was thinking about is, so in my research, I use a lot of spectroscopy. I use Raman spectroscopy to actually differentiate different kinds of antibiotic resistant bacteria. And so my immediate approach is, could you use a similar approach using Raman or some infrared spectroscopy to see if you can distinguish like healthy and infected cells? Because there are definitely different morphologies and functional changes that occur in that transition, and seeing if that can be used as an indicator of infection. And then I was thinking about some alternate chemical approach. I was reading this article that in the breath of infected malaria patients, there's different chemical compositions. And I was like, oh, if you can collect breath samples and then use some type of chemical analysis to quantify that, then that's something that you can use as an alternative to antigen detection. Just an idea.
And has that been demonstrated? Some breath?
That has been, yeah. There's some like breath. I think at Johns Hopkins there's like a breathalyzer. Yeah, exactly. And then I think the third option was just to find other antigens or any nucleic acid sequences that are still preserved in these new plasmodium species. And then so that's kind of I think like for analysis, the most immediate things I can do is just open up an RDT, try to put some electronics in, and that would be easy. And then I think the spectroscopic approach will be quite easy as well. But
so I think, a couple of immediate to-dos is both we actually do have malaria parasites in the lab. Oh, cool. Because we culture them.
Yeah.
So we can do arbitrary concentration. We should online go and buy a whole bunch of malaria RDTs so that we can represent the thin red line in a lab setting.
Yeah.
And I think the other bit on this would also just be is implementing some of the full scope optics directly on the RDT would be sort of an immediate low-hanging fruit that we're trying.
Yeah.
Make some measurements for COVID tests. I think it's not just resistive, we can do all kinds of impedance spectroscopy. So you're actually making much more clever RF measurements. And yeah, I think again, team members, working alone is no fun. So anybody who's listening online, if you're passionate about malaria, I know Marwan has been online for the longest time. I think the last 2 weeks he wasn't able to join. So let's write a message to him. He's in Sudan. He works on malaria, is passionate about malaria, so he would be a fantastic person to recruit. And you know him on Discord, just write. I think folks should try to actively recruit when you see a context that makes sense, that, oh, this would be a person that would bring, because Marwan could go out, talk to a few people to get a sense for that, collect some from, because all of these are disposed. It would be fantastic to get some disposed used RDT test to actually test what the level looks like.
Yeah.
Okay, Adil and Ben, you guys want to just say a word? Yeah, and then Ian and Nabina, could you guys reach out to Marwan for a second and then connect to Baba?
Hey guys, our project is not actually like a solving some problem.
That's good.
Yeah,
Yes.
we did actually absolutely. I would say.
Yeah, so this came out of the play and the play paper thing that we had in class, and it showed Manu one of the prototypes that Adil had worked on first. And so what came out of it was this interesting I don't know what to call it.
Let's call it a meta material.
Okay.
It's a fun
Much
word.
better.
It's a fun word in
Yeah.
in science right now. Metamaterials are materials that you don't know that exist in nature, but are purely created by humans for functionalities that go beyond traditional materials.
Yeah, so the idea that Manu had for us was to sort of play around with different things, because Adil, if you want to show.
Yeah, sure. So we started with building some construct like some form shape that can be like a stiff enough to hold something, and at the same time I wanted to make it like a foldable to carry it and let's say assemble it really fast using only one hand. So, and we built this construction like this, and then you can turn it back and can be folded very easily. Yeah. So then we showed this one to Manu, and he told us to write some mathematical model of this structure, which is we even don't know how to start this work.
We'll see
So,
it, yeah.
this structure has several what do you call it? Several
Degrees of freedom.
degrees of freedom. Yeah.
Yes.
So it can be folded like this, but it has some constraints like 90-degree this part, and yeah, and flexible part, the flexible top part. Yeah.
Yeah, so just I think the first obvious thing, and people should pass around to play how strange it is to play with. It's a combination again of stiff structures and elastic structures. That the paper has almost no resistance to bending, while the cardboard has, in this case, say infinite resistance to bending. And that changes the game of how we often think about analyzing many of these mechanical structures. It has all kinds of hysteresis. So I think, yeah, if you just collapse, open and close it. So when I open it this way, but then as you see, it collapses, different cells will collapse and not the same cells would open. So this would be called a hysteresis cycle to what just happened. Traditionally, for a normal material, you would think it should be reversible, but that's not what happened in there. For now, in a certain configuration, I'll do that again. So it's all open. If it starts to lock in, and then suddenly you see many of those cells got locked, even though I am actually pulling on it. So this is a very strange type of an effect, and it's just primarily arriving from geometry. Yeah, and I think the common way of pitching the project is, I remember hearing this, you know, sometimes you make machines to solve problems, but the other times you make materials that then make completely new machines. So in some sense, this is much more like a material. What we're inventing is a new kind of a material, and then as yet we don't know what applications that it has, but that doesn't matter at all. But if it is a new class of a material to explore, then it can be mapped and mirrored to other kinds of applications.
So the other thing that we played about based on your feedback was when you said something about reducing the degrees of freedom here just to make it easier. And so for this one, we worked with a different material. So this is foam board.
Yeah.
Where there's like cardboard, and there's a piece of foam in between. And so we just have this one bend in the middle.
Yeah.
And for this one, we basically restricted in different directions. So this can bend in this direction, but then this bends in this other direction. And there's also the thing that like all sorts of shapes that he makes when you like turn it into a circle, but I'll need to put this on the table, but it only bends that way into some sort of triangle.
Mhm.
Yeah.
So you're saying there is a flip,
this holds
there is a flip
this,
also.
yeah, this is almost always constant, where if you hold it this way, it bends all the way up to this point. And then if you hold it this way, it bends all the way up to this point. And then this.
Oh, that's very cool. Yeah. Yeah, yeah. And that does not happen in the
And
other
that does not happen in the
structure.
other one.
Yeah.
This-
No, that's very strange. Yeah, do you want to just show that on the camera just so that people are seeing that?
Okay, so this is what we're talking about, where we're basically creating this top part that has just the ability to fold in just one direction, compared to the other one that was just a flexible
And it can
material.
go both ways, actually.
And then we've restricted it in a way where this only goes in one direction, 90 degrees in one direction, and this goes in the other direction. So if I hold it this way, it's stiff all the way up to this point, but then it's very rigid here. And if I hold it this way, it's stiff up to this point, but then it's rigid all the way. And this is like straight or flat and smooth.
Yeah, but it's the same
But
material.
it's the same material.
It's the same material. So, yeah, no, that's really
So
lovely. Yeah,
we're thinking,
Yeah.
or we have material that we want to use the 3D printer to sort of figure out how to,
Yeah.
because we think that'll be faster to iterate
Yeah.
with.
Yeah.
To try different things if we print
Yeah.
all the different parts and just fix them
Yeah.
together. And see
Yeah.
what-
yeah, either you snap them together. I think having lots of units should be the first challenge. It's already clear that this is an interesting object, but having lots of units to reconfigure and play with. And I think in parallel, we'll all sit together, and anybody who's interested will write a little bit of this it's straightforward to do. This is Maxwell invented this long time ago, the same Maxwell that invented the electromagnetic equations. Framework for thinking about, why we make structures the way we do, like why is Eiffel Tower filled with triangles? He's the one that actually solved it. And he showed you can analyze these structures in a very general capacity. And I think, yeah, the thread of, I love that you guys took this challenge that the project is really display. And I mean, of course, we can structure it in an educational context to begin with itself, but we don't even have to structure that. The first bit is that if this is a new kind of a material, let's just explore what it does. Okay, yeah,
Thank
I
you.
think you guys will have a challenging FRDPARRC, but this is when you work backwards.
Yeah.
When we have figured it out, we will write what it was designed for. Yeah, yeah.
Hey guys, I had a question.
Go ahead, Alankrit.
Is there a limitation on how small you could make this? I mean, not very small, but can you shrink this? I'm thinking of some sort of a medical application where it could be maybe like a.
No, I mean, I think this is geometrical ideas are scale free.
Yeah.
What that
Mhm.
means is because this property is coming from geometry, you could make it atomic and you would still get similar effects. And so the thread to think a little bit about would be, we should test. There is a remarkable 3D printer that we do have access to on campus that goes all the way down to 5 micron, couple
Oh, wow.
micron objects printed. The mechanical testing of them, it would be that, the material properties are not the same as here. This is robust as a material. I think thinking about maybe millimeter scale might be fun.
Yeah.
And EDM, of course, would do the trick. We should think a little bit about whether there is already existed unit cell that is made in that volume and we could use it. But yeah, I think one thread to think about would be is let's try shrinking it just for fun. And yeah, Lankrit, if you're interested, join the team. Lots
All
of
right.
places where you need to go through nooks and crannies in the body. So yeah, but I think I wouldn't constrain, the project should really be about explore the mathematical and physical space of this idea rather than constraining it to a specific application, because that can come as stage 2. Any other comments? And of course, what Subhir is trying to do has sort of some inklings to trying to make structures to hold laptops and others. So in general, the whole sheet metal stuff would be really fun. So you guys should.
Yeah, I was just going to ask whether you can make it in metal, but how would you have that flexibility?
No, I
different.
think we can do the rigid part in metal, and we can
Mhm.
do the flex part in some kind of mylar or another or Kapton, something that's still very strong but flexible. I mean,
And we should not have the creep. Probably the creep is something that bothers me a bit.
Yeah, I think the
but
way to think about that would be is that the joints won't
Mhm.
be only the structural, the stiff part is metal, the joints is what we have to think about.
Right.
Yeah,
But
it's kind of
fantastic idea.
in lunch boxes and tiffins and all the
Mhm.
lead always have that plastic creep where there is
Yeah.
stiff soft and it's all made in a single shot.
Yeah, exactly. We wanted to
Yeah.
our next step is to print this
Yeah.
structure of this material. It's a PP,
Yeah.
polypropylene.
Yeah,
Yeah, which is available for 3D printers.
yeah. And I think the
yeah,
thickness will
playing with
just
thickness,
give
yeah,
you
we can-
naturally stiff. I think that's the polymers is the way to go. Unfortunately, plastics always
Yeah.
have an upper
I
hand.
love plastics.
Yes. No, I think it's, we might have to play with
Another
plastic.
way is to use the carbon fiber
Okay.
and make the structure like a cover it with resin. These
Mhm.
parts,
Mhm.
stiff parts, and these flexible parts.
Oh,
we could do.
keep it as carbon
Yeah,
fiber.
yeah.
That is fantastic. Yeah. Then we can also claim some exoskeleton
Yeah.
body armor suit for some Marvel movie. Yeah. No, I think
Just-
carbon fiber, that would be fantastic.
I was wondering if you can make the bends not too sharp. That would help in because if it folds onto itself, creep is going to kill all materials, I suppose, in the sense that creep will increase and the cracks will develop. If you can fold it, but not, what I mean is no sharp folds, is it possible?
Yeah, I think the curvature of the folds up here depends on some of the material thickness itself. So
Right.
the sheets are thick, but the fold regions are thin. The radius
Mhm.
of, I think what you're thinking about, you're worrying about the radius of curvature. There has to be a
Yeah.
limit on the radius of curvature.
Yeah, yeah,
That can come from the geometry and the scale of the
Okay.
problem.
Mhm. Thanks.
What is different between both sides? So if you notice in this one, where we restrict this, if you try to take it this way, this is restricted.
Yeah, it's
in
a one-way,
two directions.
it's a
But
one-way
this is just in
folding.
one direction.
As compared to that's the bifolding. Yeah, it folds both positive and negative curvature, and that one only folds positive curvature. Yeah, and you can also imagine if you had done this halfway, but flipped the orientation of the cubes,
Right, right.
suddenly
Right.
it would make something totally different. I think we're kind of close to the whole hexaflexagon universe
Yeah.
type. I mean, you guys should read the history of that, how it started.
It's interesting that, for example, if you control this constraint, for example, if you
Yeah.
want to like make specific shape,
Yeah.
you can just turn and off this like sides
Yeah.
left to right.
Yeah,
and
yeah,
you
yeah,
get some
yeah.
specific like.
Yeah, and I think that's another kind of a thing to think about, is another layer on top of it where configuration is programmable very simply. You know, this like a type of a cube that if I press a button or if it self-touches, that rather than this constraint, it's the other one. That's another layer even on top of it, where the structure changes as a function of time. Okay, you guys definitely need a team name. So you need to name this object. Yeah, yeah, yeah.
Okay, we'll think
We'll
about
think
it.
about it.
Yeah.
Yes, okay.
Thank you.
All right. Anybody else that hasn't done FRDPARRC yet? Okay, I guess.
Yes, I think I do some.
Oh, Marwan, you're here. Okay.
Yeah.
You were
Yes.
here for Baba's talk, right?
What?
Did you hear Baba talk about the malaria project?
No, no, no. I missed this part because
Okay, I think just talk to Baba. I'll ask him to connect with you on Discord.
this is good.
Yeah, but then you should go ahead. What is the problem that you're thinking about?
I think in the problem I need to address is the access to science education. I need to go to this link.
Yeah, should I go on Discord?
Yes, yes, I create a channel, but I think it overlap with the other guys. It embedded in the last channels, but here in the Google form, my summary.
Where it is? It's in the Zoom chat as well. It's in the Zoom chat. Oh, I got it. Okay, I'm just sharing that. Yes. Oh, I love the name.
Yes.
Sorry, that is beautiful. Okay, go ahead, Marwan.
Okay. As I said before, Nature Diary, it is a some and old extra curriculum in Sudan elementary education. But here I am inspired by the idea of full scope. The problem, as I described in idea board, how to increase the student connection to his local context, because I think the way we study the science, it is a more as a banking system, just we memorize the idea of a science, not really connected. So that this is very important, because we have a some proverb called that the life is the school. So we need to have this bottom-up approach to learn from the environment. Second, how to enhance learning to be peer and community social process rather than individual achievement, and foster learning by doing. The last, how will the local environment be the learning environment, where biology, physics, chemistry will be explored and learned by the group and put into the action of daily living activity. Just we can pick through disease like malaria, we can learn a lot in biology, starting from the insect, Anopheles, to the parasite, and to the diagnosis, and to the all life cycle of vectors and parasite and the illness itself. In Fermi analysis, we have a disaster in our education, especially after COVID. The recent report from UNICEF, there is approximately 6.9 million children were out of school. This is almost 40% of the age that will be in school. And this will be, as indicated by the report, without urgent action, the learning crisis in the Sudan will become generational catastrophe. The other,
Marwan,
yeah.
can you just say a word about the, just like around the world, there was primarily push for online education. Are there specific factors in Sudan that make this even more challenging in terms of has the return back to school not been fast, or is this that we have lost the students now, that they're not even coming back even if the schools were open?
I think we have a very complicated issue, and the corona, it just makes the problem, it is severe. We are not ready to have a curriculum be online at that short time. This is the one. The other thing, we are in transient period. We have a revolution. We step down dictatorship, and we have a transition government. Then we have a military coup, and all this dynamic, it collapses. The other very critical, there is a hyperinflation during these 2-3 years. In Khartoum, maybe even going to school, it is a very costly. And some children be out of school to just support their family in the crisis. But the inequality and the out of school problem, it is not just as exaggerated in the last 3 years, because we have a report since 2014 from UNICEF again. At that time, we have 3 million children out of school in 2014. And that's why it is a problem. And even this is a just access to education, but the quality itself, it is a problem. That's why we need to make some problem. The next point, that there is inequality in access to education, especially in conflict zone, in Darfur, in West Kordofan. Maybe the difference point be up to 20% in enrollment percentage in some states, and this is a difficult also. And again, this access to inequality in access to education, it results in access to science, because these state in the secondary school, they have a very few seats in the STEM-based faculty, like medicine, like engineering and other science. And this also emphasizes the problem of marginalized and conflict prone area. There is some epistemology in how we educate as a science. I think the all education is ineffective and detached, because it based on a banking system. And we have a proverb states that al-qalam al-ma bizil balam, that means the pen that does not eradicate ignorance and shame. So that they describe this is ineffective education. There is education, but people see there is no change in their life because of that education. All this problem led me to be very critical about how we address access.
I mean, the fact that you have a proverb for it, it's just so beautifully said, because if you think about it, you can take it for granted that, oh, we just provided a pen. that should take care of everything. And so just because we built a roof and just because we built a system that is supposed to provide education, but if it's completely ineffective, then it's almost as if it doesn't exist.
Yes.
You know, it's really ironic because I often give the example of pens and pencils as a tool for democratizing science and access. But I can also understand if you give a broken pen or a pencil to someone, that does not eradicate ignorance and shame. I mean, yeah, this could be the T-shirt for Frugal, the Frugalist 2023 class. I think unless somebody has a better contender, I think this should be our motto for this year.
Yeah. Thanks. So in functional requirements, first of all, we need to build a scientific attitude that promote and energize curiosity, discovery by exploring local environments that students live, so that they can learn the biology, the taxonomy, the plant, the seeding, the weather, physics, chemistry by exploring their environment. Then they build a real scientific attitude, not just memorizing. And I think FRDPARRC will play a vital role in the area of biology and environment. The second one, we need to have low cost and affordable access to science kit, mainly FRDPARRC. And I think also weather station will help to make the observation better and to know how to read the sensors, how to make a very long observation attitude and recording and reflecting the way. Raspberry Pi for very small computational thinking, but in integrated way about physics, chemistry, and sampling and statistics, and very affordable chemical kits for diagnosis, and so that it is a pedagogy approach. We need to have a sum of inquiry-based pedagogy embedded in the activities, how they do these activities. Also, we need to promote peers learning. We can have collected the sample, then we reflect it, then a student can discuss. This is very important to make a community, scientific community and scientific groups. We need to have a citizen-based approach to have engaged learning by doing with your relevant problem. I think even health like malaria can be tackled in very learning-based approach. And in agriculture, it is we have local crops. We can teach the biology of the plant, the taxonomy, the morphology, the insect, with a certain agriculture and crops, and we have a long observability period since the plant down to the harvesting the plant, and this will be very learning journey to students. Also, we have a problem with the water and water quality, and it is a very amazing to see what is the microbiological activity in the water, what is the access of minerals or deficiency of minerals or something like that. Water quality is important, and even the environment, the drought, the biodiversity. We need to have a continuous learning and computational thinking through sampling and basic statistics. This is a functional requirement in integrated way.
And then one thread, I was going to ask just a few sets of questions, and any questions for Marwan. One I'll start with is, for the functional requirements, we should put an age group. Although the sets of interventions should be for everyone, but sometimes to narrow that down, it's actually very valuable, because I could see change is needed at every step, but sometimes narrowing that problem actually enhances and focuses. So if I was to force you to choose between, I would say, between 6 to 10, 10 to 16, and 16 to 24, which is kind of college age, middle school, or we call the high school, or no? You know what I mean? Yeah.
Yes.
All the stages of school, where would you put the first emphasis on? Just for the purpose
I
of
start with children. I start with children.
Youngest would be then 6 to 10.
Yes.
Okay. And then, so here are a couple of to-do items that I want to put on your plate, just to engage broader group of people. I'm very happy. There are several sets of people that had reached out on building the educational trust. I mean, the pilots that we would do, I don't know whether the boxes have ever actually reached you at all or not. Do we know if Jasmine is shipped to Marwan? Marwan, you've sent your address, right?
Yeah.
Okay, so I'm gonna check, or maybe Ellie, can you check with Jasmine? Yeah, I think, so we'll check on the shipment just to make sure that the first round of full scope implementation, you should identify one teacher, one specific school to work with, but also just to engage a lot more people in the community. I could sense on their faces when they were listening to you that there is a hunger for engagement. And one way of doing that would is share, for example, some of the curriculum that's currently used. That would actually be culturally really educational for a lot of us. I, for one, want to see what does a 10-year-old learn in Sudan in their science class. And just much from a context of first even understanding the breadth of the problem of what you describe, a pen that doesn't remove ignorance. And then the other part of this would also be, in the functional requirements, the notion of bifurcating between formal versus informal approaches to learning. Are the kinds of things that we are opening up taking away the school time? Or it turns out most of the people actually don't learn in a classroom, and they learn outside when they're playing and they're engaging. And sometimes this is also a way to move around bureaucracy, because in bureaucracy, it's about, unless if it's the government officially approved curriculum, you can't teach it. And so that requires politics to happen. While in informal education, you can build programs that say, this is an evening program for 4 to 6 p.m. for anybody that wants to come. It still runs right outside the school, but it's not trying to fight with some minister of education that it should or should not be implemented. So that's another key difference in functional requirements just early on. Although what's valuable, and I think I can see the vision in your words of tackling many. I mean, I think what you said about malaria and education is a very powerful thing, because health and education are deeply connected, and especially kids are the ones that actually get sick to begin with. So there's lessons to be learned. Any questions for Marwan? Any threads on? I have a tough one that I've been thinking about, which we don't have to take online. We can think about it. Is, I've known this, that conflict regions and diseases go hand in hand. So with malaria, we know this in India, for example, many Naxalite areas and tough areas where healthcare falls down, the diseases take hold. And I think there is a similar type of a relationship in conflict regions and crumbling education systems. And so, you brought up the notion of the the inequality in access in conflict zones. What's
Yeah.
the current state? Because, from far away, it might appear that this is a conflict zone. And for people who have the privilege to say, oh, of course, let's put that region in our travel ban list, and it's out of sight, out of mind. But clearly, in these regions, people live and live their daily life. What does that mean for a child currently to be in, say, one of these conflict zones or have had a past of conflict zones? What does that look like from an educational setting? What is the last way of saying this is the last straw that breaks the camel's back? What's the
Yeah.
current status if you were to pick a conflict zone?
Just we have some series. I am active in NGO called Sudanese Knowledge Society, and just the couple of weeks we are active in a series of seminars that let the people from Darfur speak out about their problem. They pick the violence as a major problem, and after that, we said to them, we are not just stick about talking about the problem. Then we need to have the problem, and then we need to have some connection to the solution. So they pick the violence and their effect to education system, and at the next Saturday they talk about the violence and its effect to the health system. I just wonder when I try to explore the malaria, when I see the statistic about the death rate, this area, it is more vulnerable, and their rates, it is just higher than others area. It is about I think 6 or 7% more than the average.
Yeah, I think, again, this is also, it's very valuable to understand, and especially if there might be another NGO in that space, and it would be valuable to see, because we have been running a program in Iraq with Mohammed Abbas, who was in the class long time ago, but is a full scope user itself. And he's described over the years, I mean, the program has been running for 5 years, and he describes the sense of broken trust among people sometimes, even in educational activities. So he runs street programs, and he will run an educational program on the streets that everybody is welcome. And most of the time that goes very well, but sometimes in areas that he has never been before, there is a sense of mistrust, which, like, if you're bringing something new, you're bringing, there are challenges around mistrust because there was prior conflict. And I think, it was prior ethnic conflict. And so he's been thinking quite a lot about how to approach and reach that problem. And effectively, what are the types of organizations to actually engage? Because, of course, children are children now, anywhere they are, they just are there to learn. They don't care. But effectively, it's valuable to think about what are the effective partnerships to be made when we're thinking about educational interventions in conflict zones. Another program that we learned from, and I don't have the right answers for, but we implemented an educational programs in juvenile prisons in the US, and also for lifelong prisoners. And it's, there is certain sets of conflicting threads, but effectively, again, it's a type of a program that requires people have had a very rough and tough life, and then now they are eager to learn, and structuring those programs carefully and thinking about what people have gone through in the past while building their capacity becomes incredibly important. So that's another class of programs to actually learn from, because just, the first thing to get removed whenever there is a set of a conflict is the educational infrastructure. Because again, if people don't feel safe, it does not make sense to continue that framework. But the return for that in Iraq, for example, has been incredibly slow. So even after the war ended, most of the places still the attendance is actually very, very small. So, I think my intuition is this would be a valuable discussion to keep having while in your broader functional requirements. If you choose two places, choose one where there is conflict and one there is not as a comparative points itself. Because it might be that the approaches of applying these ideas might change.
Okay.
Okay, and I think we're gonna run out of time because today there is a survey and then I have to go to the med school to give a talk. Was there anybody else in the team that hasn't had the chance to do a FRDPARRC yet?
We are still working on it. Would we be able to present next week if that's
I
an
think tomorrow is the last day. That's the deadline. I just made that up, but present tomorrow. Yeah, it's it's not worth waiting, because otherwise time is going to run out. These discussions is exactly why I run this class, I have to say, because this was the ideas and conversations we've had for the last this week itself is just the whole reason to be in this class. Otherwise, you can just watch YouTube videos and be done with it. Okay, so we're going to call it a day. And please make sure you try to recruit folks. There are a couple of mentors that I'm going to now ask. I'm asking all the TAs to also join certain teams. So you all have to join a team. So you should choose a team that you want to join. And then again, the TAs, based on bandwidth, you guys should just informally mentor as many teams as you can. I'm going to try to do the same thing, but we have to. And then Subhir and a couple other people I'm going to bring in now because the teams are almost set. So I know the right kind of people to bring on the table. And the folks that have no projects, please make sure that you join the teams that already have phenomenal projects. And you will learn a lot, even if it's not in your domain. But let's try to make sure that we have teams that have plenty members. Yes?
Okay, thanks.
Okay, I'll see you guys tomorrow.
Okay.
Thank you.
Bye.
Bye.